What's good, everyone? We're going to be continuing on with the multi-agent architecture series with Strands in particular. And the last architecture I kind of wanted to explore for now, at least, and obviously we'll update the series as more and more patterns come in and more developments come in, is the swarm architecture. Just as a bit of a recap, and I recommend looking at like the previous multi-agent architecture video to kind of understand everything that's available and the different general multi-agent patterns that are out there. But as a bit of a recap, right, we talked about different architectures such as agents as tools. We talked about graph-based topologies such as sequential, how you can maybe introduce conditional edges, and then how you can maybe even have some sort of kind of parallelism within your workflows. And we also talked about, right, how graphs, especially for you as a developer, give you a lot of control over workflow orchestration. And especially with conditional edges, you can kind of dictate when which agent should execute what, which agent should be triggered upon what condition, and things of that sort. And we always talked about how if you want control, a graph is normally the best way to go while still retaining some of the autonomy an agent has to make decisions with its tools and course of action that it should take. Now, the complete opposite almost of this is the swarm. And in a swarm, right, we're giving back autonomy not just for an individual agent, which already existed already in within graphs and things of that sort when they're picking between tools, but we're giving autonomy to the entire system. So what we're simply going to do is we're not following anything like a supervisor and here's a bunch of sub kind of workers that you can kind of pick from. What we're going to say is you decide the workflow. Here's a list or array of agents that we're going to pass in. Each agent will have its functionality, and depending on the instructions and the use cases and capabilities of each of these agents, maybe perhaps the tools that they have accessible to them, you decide what the right course of action is or pathway to take. So this is the architecture you want to follow if you have less control that you want as a developer and let the system make decisions. And there's obviously pros and cons. One of the pros is obviously you have to set up a little less, as we saw with the graph. You might have to code a little more, define your workflow, define the conditions and things of that sort. And it's also super neat when the agent itself can take the right course of action. You don't need to really worry about that. But the con obviously is if it makes the wrong choice. And then it can also get caught in something kind of known as ping pong behavior, where it doesn't really know which agent to hand it off to, and it kind of gets stuck and just kind of bounces back and forth between different agents, right? And we'll explore some parameters that you can set up to kind of counteract this a little. But those are some of the challenges, right? There's a trade-off when you obviously give away less control in terms of the type of performance it might have. But for use cases, right, where you might have kind of like competitive intelligence, you want agents to almost like butchering spelling again. You want agents to almost like compete and then also have like full out autonomy, right? In terms of which process to go forward with and stuff. These are very powerful. And especially for me, at least the way I'd see it is when I have basic workflows where I have a general idea of what actions should be taken, then I'm okay with going with the swarm route because for the more complicated ones, right, where there might be many nuances with conditions and things of that sort, then I'd probably stick to a graph where I can define that just to avoid any potential errors. But when the system is in place where you know there's only a few courses of action that can realistically happen and you're okay with any of those scenarios, then a swarm makes sense to go forward in that way. And the use case we'll be looking at today, right? We'll get hands-on as always, go into the documentation for a bit after this, is for example travel booking. This is a common multi-agent example. We're going to simplify it even more. Obviously, you can access real data, set it up as you need. But for travel booking, right, we often need kind of like a itinerary planner that kind of brings everything together. There's a lot of components like hotels, activities, and flights. And you want these agents to be able to work with each other, and this is specifically called handoffs. And you'll notice these are special tools and strands that enable for these swarm-based agents to kind of hand off to each other with the shared context. But essentially, you want these agents to be able to work together and have a shared context of the info that's been accumulated. So for example, if I'm booking a trip, right, depending on when I've booked my flights from when and where, I'm going to plan itineraries or hotels around that. So you can imagine that you want this swarm to have a shared resource pool where they each have access. So that's another kind of pro, if managed correctly, obviously, and if it takes the right course of action, is it has that shared context between each of these agents where they can access the data that maybe the other agent has outputted and then take the right course of action from that, right? So a lot of this becomes simplified for you, whereas within a graph workflow, you kind of have to maintain state, parse what the other agents outputted, things of that sort to kind of dictate your workflow. So this is another big reason or big way in which swarms work that also kind of simplify the developer experience for you. And now if we go right into the documentation itself, and we'll come into the sample in a little. I executed this ahead of time, but we'll explain everything in a second. If we go into the swarms documentation, right, as we can see, it's a collaborative pattern, a collaborative orchestration pattern where these are the kind of main things that you want to keep in mind. It's autonomous agent collaboration. There's no central control like you would in a graph or agents as tools kind of architecture with a supervisor. And then basically, right, this is a collective intelligence. So that shared context that each of these agents have, that will propel it to make the right decision, right? And you can see that just in the documentation in terms of it has access to the full task context, and then also more importantly, the history of what agents have worked off on what. And the dynamic part of all of this, right, is within this swarm, there's this handoff tool right here that is baked into each of these agents in the swarm itself, where it says, I'm going to now hand it off to this agent to solve this problem. Here's the context that we've gotten so far, and here's the history. So that's how you can envision it. And you can imagine the shared context being something like this, right? You can see the previous agent's outputs, where the last node, for example, was in terms of its implementation, and get an idea in terms of it. We can obviously expand on this, and I'm sure we'll make future projects where there might be multimodality. Some other use cases might be like generating a report, analyzing that report, maybe like, like doing both visual and textual analysis. So there's many different potential use cases that you can go in terms of your kind of swarm-based architecture that we'll continue to explore. But for today's sake, right, and before I get into Cursor, I'll also link this down below. This is all open source. Remember the Strands SDK. I often, when I'm like new to SDK, I kind of come in and I explore the code itself, and you can see a lot of the different input parameters and things of that sort that go into many of these API calls to get a better understanding in terms of the orchestration itself. So I recommend looking at that, but let's hop into Cursor real quick for our travel agent type example. So to get started, right, I have a few different agents that I'm working with, and I've defined them in my config file as always. And here I'm going to use Bedrock Cloud 4, Cloud Sonnet 4, sorry, from Bedrock, via Bedrock, to kind of power all of these agents. And I'm going to have 5 different agents. I'm going to first have kind of a fun fact or informative agent where if you say query, like, hey, in this case, we'll use Tokyo. Hey, like, I want to travel to Tokyo, give me some fun facts about the destination. Don't give too much information. Then I'm going to have 3 separate ones for hotels, where in this case, I just said make up some hotels if you don't have much information. You can obviously streamline this, connect it to maybe some sort of API or something of that sort. I want to have an agent for hotels to recommend hotels. I have an agent to recommend flights. Once again, you can plug this into real-time data. We're not going to do that in this case. And I have an agent that will be connected to different activities and things of that sort. And finally, I have an itinerary agent that ideally, like depending on all this data, can kind of bring everything together. So like I said, I have a general idea of the type of workflow it should take. I don't really want to have to define it. I don't care if it does activities first or hotels first, for example. But ideally, I would imagine it would first book the flights and then look at places to stay and activities near there. Hopefully, that's the type of course of action it takes, and hopefully these agents will know to work within each other, right? And I've defined these agents just using strands. Just look at the intro video for that too, once again, if you're new to the framework. But I basically define them, same model for all of them. I have the different system prompts that I define there that I'm working with, and these are my different agents that I'm going to be using. And once again, I've not defined like a supervisor, I've not defined a workflow. These are just all autonomous individual agents with no connection to each other at the moment. And if we go into my main Python file, just set up some logging. I grabbed this directly from the Strands documentation. You can use that too as well there. And here I'm actually going to create my swarm. This is the new object that we're working with here basically. And what we'll first do is we'll pass in a list of our agents. So once again, just an array of agents, no workflow defined or anything of that sort. Then we define a few key kind of parameters here. And this is the important part that you can toggle and play with. If you remember earlier when we were drawing out the theory, we discussed the ping pong behavior. Sometimes when a swarm or a completely autonomous system gets confused, it tends to just bounce back and forth between 2 agents. When the agent roles, for example, something that could lead to this is if your prompts are not delineated clearly enough. And if there's not clear instruction there, I know it's basic English, but you kind of need that. It can sometimes lead to agents just bouncing back and forth and not hitting the agents it needs to in the workflow. So you can set these parameters where it's saying essentially there has to be at least n number of unique agents in the last amount of handoffs. So as we know, these agents have a tool called the handoff tool, which will essentially give the context and history so far to the next agent basically, and it'll hand off that information essentially. So we're saying, for example, in the last 8 handoffs, at least 3 unique agents must have been hit. Let's say it was just 2, it's likely that it's just bouncing back and forth between those 2 rather than actually going through this. Obviously, you want to adjust these numbers depending on how many agents you actually have. But in the case, right, with swarms, normally you will have multiple or a larger amount of agents that you're working with. And then we define a few timeouts here in terms of the entire swarm execution. We're going to cap at 15 minutes, 5 minutes per agent, just different parameters you can play with. Like I said, this is all stuff that you can see in the code as well and the documentation. Obviously, it's a little cleaner here in the documentation in terms of the parameters, but you can see in terms of the best practices, the different types of things that you can set up, and then the configuration specifically too, in terms of what the default values are and what each of these mean basically. I set this up then, right? And then all I'm going to simply do is enable my logging just to get some like visibility into how the swarm is thinking. And I passed in a sample input. Plan me a trip to Tokyo, generate me an end-to-end itinerary that includes flights, hotels, and activities. I didn't give any information in terms of what to hit first. And I ran this a little earlier because it takes a few minutes to execute, just so we could kind of visualize this end-to-end. And obviously you can run this in your own environment and also kind of adjust this example. But if we see here this kind of chain of thought of thinking that it has, we see that initially processes this with the kind of informative agent, and we can see there's a handoff from agent to agent. So since we're looking for a complete end-to-end itinerary, the initial agent processes that, and then we'll see that it has to connect it to the appropriate agents. So the itinerary specialist, for example, will now work with the flight, hotel, and activities experts to plan the trip, sorry, right there, right? And then we'll see here, it does another handoff basically, and now it's working with our flight specialist, which is our flight agent that we're using. And we'll see that there's dummy flights that are kind of recommended depending on whatever input that you've planned. Then it hands it back actually to the itinerary agent to kind of update the state. Because the plan was, right, we need flight, activities, and then hotels as well. Now that the flights have been updated, we can see that it then goes to the hotel agent. It says itinerary has been updated basically. Let's now update the hotel essentially with it. And now we get more hotel recommendations and a very similar kind of chain of thought for the activities agent basically, right? So we'll see a handoff once again to the appropriate agent there, and then it will give us a bit of itinerary that goes through this. And if we remember, I told the itinerary agent in the config.py or the prompt basically to kind of summarize this end to end. So after it's worked with all the different necessary sub agents or agents in the swarm that it's working with, sub is the wrong word there because once again, there's no workflow here. You'll see then that it gives a final kind of itinerary that balances everything. It says here's the flight, here's basically the hotel options, and here's a daily itinerary. And what I did here to kind of streamline this, right, and once again, just borrowed it from the documentation, this will make it clear. We have a list here of the node history, so the different agents it hit. So it first went to the informative one, which processes the input, gives some fun facts as we said in our agent. It then goes to the itinerary agent, which is kind of the mother of all these different activities, flights, and hotels that we need to plan, updates it with the flight agent, returns that to the itinerary, updates it with the hotel from the hotel agent, updates it with activities, and finally the itinerary agent kind of gives you everything back as an output, which is this final text that we saw here. I just printed everything out so you can kind of have an understanding of the thought process that's going on here. But as we can see here, right, we really didn't define any workflow, and it went through this end-to-end. You can obviously go that route too, where you do define it via the graph. There's no problem with that. And you can probably do all 3 of these in parallel, right? Flight, hotel, and activities. So you want to think about these types of trade-offs, but from a developer perspective, right, it's very, very simple to use a swarm. So think about the pros and cons in terms of, are there a lot of different edge cases I have to account for? In that type of case, I should probably go with a graph. If this is a pretty simple kind of end-to-end workflow and I'm not really latency or like throughput confined, and I'm happy with the performance here and the way the decisions the agent's making or the system's making, then Swarm's a great place to get started and really kind of prototype and iterate over. So that, what I'd say at a high level, is what I had for today. This is another interesting pattern when you're thinking about multi-agents. As we talked about at the start of this series, everything is just pros and cons. There's no right or wrong here. There is probably a wrong for some cases, but just look at the pros and cons for your system, derive the best kind of architecture from that, and just go ahead and implement it and prototype with it, and you can kind of experiment and get a better feel. But that's mainly what I had for today. Thank you as always for watching. If you enjoyed the video, feel free to leave a like and subscribe. If you have any questions or doubts, leave them below in the comments. Feel free to connect with me on LinkedIn or Twitter. Reach out there as well, and I'll be sure to get back to you. Thank you as always, and I'll be back with even more in the space. Thank you.